How, first of all, we saw what sort of questions can the examiner ask. Secondly, we saw how to prove their identities as well. Oh, if you know what sort of identities are given to you, what sort of identities are in your syllabus, these ones. And then we saw that we began with how to prove identities. And I told you guys that, you have to choose the side. That is extremely important. Secondly, simplification is always easier than expansion. And lastly, you need to identify the required functions needed to be proven. Now we're going to apply all of these statements into a question. The question states, this is an easier one. So the question states like, for example, mm, prove. Usually the questions are, the question statement says prove or show that or something of that sort. So it says prove or show that mm, 1 minus cos square x over tan square x. Oops. Is, and there's always three signs for identicalness. Cos square x. And the question is of 2 marks. So the question says prove or show that this side is what you may call um, identical or what you may call to this side. All right, that is what the question says. Now, what's going to happen over here is I'm going to apply all of these rules and I'm going to prove this side to this and I'm going to prove this side to this as well. And then I'm going to ask you guys to choose which method is easier. Okay. Okay. Let's start off with what you may call um, simplification, my method, because this is going to require, if I choose this side to prove it to the other, that means that I'm going to simplify this, right? This is a larger fraction. This is just a singular term. I can easily, write it like this. That's one way of doing it. Secondly, what's going to happen is that I'm simply going to what you may call this side. If I choose this side to prove it to the other, I'm simplifying it. So I'll choose this one first. We'll see that I've chosen this side. 1 minus cos square x over tan square x. And we already know the identities we've studied above as well. So clearly off the bat, I can, write it down as that sine square theta or sine square x is equal to 1 minus cos square x. That is what comes, directly to me just by looking at this. So I can replace it. I can replace it how? I can write this down as sine square theta or sine square x over tan square x. All right. Secondly, if I look at it, I can also see this tan square x written over here. And I remember that tan x was equal to sine x over cos x. But because this is what you may call tan square x, that means that everything else will be squared too. So this can be written down as tan square x is equal to sine square x over cos square x. Very simple to do. Now, what do I require over here? It says identify the required functions. I need cos square x in a numerator with no denominator. So I just need cos square x. So I need to remove the sine square x, I need to remove this tan square x and get to cos square x. How do I do that? Let's see. So secondly, what I can do is I can replace tan square x with sine square x over cos square x, which will give me what? Sine square x over, or we can write it like this, over sine square x over cos square x. Because these two are dividing with each other, I can simply take reciprocal and it will be sine square x times cos square x over sine square x. And you can simply cancel out sine square x, cancel out sine square x, and the final answer will be cos square x. Hence, proven. All right, you have proved that the sine square x's and cos square x's are like clear. All right. Any issues with this, Nofal and uh, Parsa?
No, sir.
All right. Hopefully, this is clear. Now, this was one way of doing it, and I think that it's the easier method. Technically, it involved only two steps. Three, if you count this simplification one, and you were done with it. Clear? Now, let's do it the other way around. What if I don't choose this one? What if I say that, I have to expand if I choose this side and I need to expand it to the other side? Now, I'll explain how this is much more difficult than this. First of all, you get cos square x. Now, it you have to develop some sort of thinking because from cos square x you have to think that okay, I need to somehow derive from cos square x. Two things can be driven. First thing can be that cos square x is equal to 1 minus sine square x, or cos square x can also include what you may call using this guy, sine square x over tan square x. Just simple algebraic manipulation. Clear? Secondly, what's going to happen is that now you have to, once you've gotten through with this, now you don't know what to convert cos to. You can convert it to either one of them, but how do you know what to convert to cos to what? Cos square x needs to be converted into some sort of, you need to now look at into your required function. You want a tan square x in your numerator and you want a 1 minus cos square x in your in your numerator and a tan square x in your denominator. So therefore this answer is only giving me the tan square x. So I can simply write this down as uh, sine square x over tan square x. All right. Now this becomes a bit more simpler. Sine square x can be written down as what you may call this guy, 1 minus cos square x. Write it down and you have to just display it. So what is it going to have now? You're simply going to convert this down to sine square x is 1 minus cos square x over tan square x. Is this clear? And you can again say that we proved it. Now, even though it clearly looks like that the second time I did the question, it was a bit easier to do so. Looks like, maximum 2 steps and that is done. And this looks as if, oh no, I did more steps. But if you look into it closely, this was pretty much, you can say pretty straightforward. Why? Because the shape of your identities was already something that you were accustomed to. All right. You were really accustomed to your identities. How so? Is that simply if you look into your 1 minus cos square theta, 1 minus cos square x, that can simply be written as sine square x. So you converted it. And tan square x. So the identity usage was very straightforward. The shape was extremely straightforward. All right. Okay. Over here, you were given cos square theta, and in order to convert it to sine square x over tan square x, you needed to manipulate an already given identity, which was that tan square x is equal to sine square x over cos square x. Then you would have just simply written it as cos square x tan square x is equal to sine square x. And then this would have just been written as cos square x is equal to sine square x over tan square x. Clear? Is this clear, guys? Now it is up to you which
Yes,
method
sir.
you guys use. It is up to you. I have absolutely no preference. But my opinion would be that you guys use the method which involves simplification rather than expansion. Because at the end of the day, you're going to get 2 marks. Regardless of whether you think so much about it and you manipulate identities, even though this looks as if it's 2 steps, the thinking process behind it is far more steps. If I had done this step first, if I had attempted this method first, then you guys would have been a bit more shook. But because you had already seen how the identity was proven in the first one, that is why this looked a bit more easier. Is this clear? So my advice to you guys would be to use simplification. It can be done both ways. I have already proven that it can be done both ways. You can get 1 minus cos square x over tan square x is equal to cos square x. You can prove it this way or you can prove it this way. Your call. But we have seen that simplification is easier. All right. And you have seen how I have identified. I have also identified the required functions. Like, what did I require? Because over here it says cos square x is also equal to 1 minus sine square x. I could have used this identity as well. The reason why I didn't use it is because my required function was tan square x. And where was it required? In the denominator. So I had to use this identity so that tan square x could get into the denominator. And from there on, you knock off one at a time. Is this clear, guys? Is there anyone who does not get this? Let me know. Yes, Parsa, Nofal. Any issue?
No, for no
No
issues.
issue, sir.
Like, let's look into another example. And this one was the easier one. Now let's look into a difficult one. The question says prove. Usually it says prove that, show that, whatever it is. Prove sine x over 1 plus cos x is identical 1 minus cos x over sine. Now, over here, it takes a bit of, a bit of thinking is required as compared to which side you should use. Now, the reason why I can think of using this side rather than this side is because in my mind I can convert this to this. And how can I convert it? Okay, what I'm thinking is that if I take this side, maybe add 1 minus cos square cos x or something of that sort. I could get cos square x or some. So in my mind, I'm thinking that sine x in the numerator is much more easier for me to understand. All right, that is what my thinking process is. Always remember, in proving identities, you guys are going to have to think outside of the box because there are multiple ways of getting to the same answer. So over here, a bit of creativity is going to be used as place. The tips and the techniques you already know. Simplification is easier. You need to choose the side, which is easier to do. And also, I've always said you need to choose the side which is easier to do for you. It may be difficult for someone else, but it may be very easy for you because everyone's completely different. Okay, I'll do this question using the left side. Usually, this is a popular choice. Why? Because I don't know why students think that you should always choose the left side to the right. No, that's not the case at all. You can choose that. The examiner has completely left it open-ended, that you can choose whatever side you want. I'll choose the left side and I'll write down sine x 1 plus cos x, and I need to prove it to 1 minus cos x over sine x. Now, in my mind, I can think of 1 plus cos x can somehow become, what you may call sine x, because through cos you could have the tan, and then through tan you can go to the sine. Okay, that makes sense. But from sine x, it seems very impossible to make 1 minus cos x, because even if sine x is equal to tan x over cos x or something of that sort, it can never get me 1 minus cos x. So what I'm thinking is, what if I multiply the entire equation or the entire, fraction with 1 minus cos x? You know, apply a cheat code. I multiply. And because I multiplied the entire equation with this, now what would I get? I'm going to get sine x times 1 minus cos x over 1 minus 1 plus cos x and 1 minus cos x. All right. Now what's going to be the case? One thing that you guys need to know is that this can be written down as what? What does this look like, guys? Doesn't it look like, if you guys notice it clearly, 1 plus cos x, 1 minus cos x, doesn't it look a lot like a plus b, a minus b?
Yes.
And therefore, because it looks like a plus b, a minus b being multiplied together, can I not simply write this as a square minus b square? And now, if I can write this as a square minus b square, then that means the above part can leave. You can leave as it is. Sin x, 1 minus cos x. We'll get to that part later. Over 1 minus cos square x. Because technically it should have been what? 1 squared minus cos square x. All right, but 1 square is 1. So at the bottom, now in the denominator, you're getting 1 minus cos square x. In the numerator, you're getting cos square x. In the denominator, you're already getting 1 minus cos square x. Now what can you do? Yes, guys. Hmm. I can use my identity. Now, what was my identities above? My identity over here can be that sine square x is equal to 1 minus cos square x. And therefore, what I can do is that I can simply write it down. So then I can get sine x 1 minus cos x over sine square x. So now what's going to be the case? Cancel out the sine, cancel out the squared. Because at the bottom you've got sine squared, in the numerator you've got sine alone. And finally, you get your answer as 1 minus cos square x or 1 minus cos x over sine x, which is your answer. Is this clear? Farsa, Nofal, any issues with this? Let me know.
No issues, sir.
No issues.
All right. This was a tricky question because it wasn't that straightforward. Why? Because you had to integrate something by yourself into the question itself. Is this clear? So sometimes you have to go with a gut feeling as well. I had already, even before, if I think about it from a student's point of view, I already knew that in my numerator, there was absolutely no way for me to integrate 1 minus cos x. From 1 plus cos x, I could still, I could still imagine getting tan or getting something of that sort into the equation to at least get sin x. But from just sin x, it was virtually impossible for me to get 1 minus cos x. So I multiplied it with 1 minus cos x, to get some sort of traction. And from there on out, I just simply, used my algebraic manipulation skills. Clear? That is why this is also, this was just algebra. All right. Is there anyone who has any doubts regarding this? Let me know. This question would also be of like 4 marks max. Not a lot. Yes, guys.
No, so no questions. It's kind of easy.
Well, okay. That is that is nice to hear. Well done. All right. Let's see. Let me give you more questions. First part says saying it's easy. I have to raise the difficulty level. Hmm. Okay, this is a bit too much a raise of like uh I didn't want to do this, but Parsa made me do so. I've like completely gone higher up in the difficulty level. So this right here is a past paper question, which will appear on your screen now. And I want you guys to attempt this. Haha. Okay, in these type of questions, I will again say simplification is much more easier. Getting two fractions and simplifying them to a single fraction, easier. Getting one fraction, expanding it to two fractions, difficult. Common sense. It's much more easier to break cake down than to eat cake. All right. And also, if the question is what you may call if there's a question in which you cannot really figure out in this scenario where you did not know how to which two identities could have been used. I always give out the example of like it's going to be very easier for me to have you guys ever had the experience of like have you guys ever seen modified cars or something of that sort? I think you have. Like,
Yes.
some people upgrade their cars. They take an older car, the same version of the car, and they upgrade it to a newer model. People do that a lot. Like they take an older Mercedes and they, add body kits to it and they, make it into a newer one.
Convert it.
Yeah. Do you think that it is easier for me to convert a Mercedes to a newer Mercedes or to convert a Toyota to a newer Mercedes? The Mercedes, obviously, because
Yes.
similar features, that is the what we did over here. What I needed was sine square and tan square. I needed my tan square in the denominator. That is why I used this identity. There was no use of using this identity. It could have been done, but why? Choose the easy way out. Work smarter. Don't work harder. All right, do that. Okay, write this down, guys. Guys, also take a screenshot of this question so that I can take out more questions. Both of you
Answer.
done with the question?
Yes.
Wow, that was lightning. And what about you, Parsa?
No, so still doing it.
All right, no worries. Noble, do you know of that modifications guy called Mansoori?
The brand which modifies cars.
Yeah, yeah.
Yes.
Hmm. I don't know why it came to
You
my
know, one
mind.
of my neighbor has one of that.
Your one of your what has what?
Neighbor has Rolls Royce Mansouri.
Hmm. By the way, I would never, like want that, to be honest. If I'm getting a branded car, like not a branded car, like a car from a bigger brand, like a Rolls Royce or a Mercedes, I wouldn't want to modify it. Like the car itself is amazing.
But some of them look good, like Brabus.
Yeah, and yeah, I could never understand what Brabus was. Like Brabus is the Mansouri type thing, right?
Yes. It just makes it more mafia type.
Hmm. Yeah, and then they have the like the big B on it. A friend of mine once he used to he used to deal in cars. Like he used to buy and sell cars. And once he got, I don't know from where he got that, but he got a Brabus G wagon from
In
Mercedes.
Pakistan?
Yeah, I was shocked. I didn't even think that Brabus. I didn't even think G wagons were possible. He got the Brabus one. Like he didn't get it. He what you may call
Imported
he
it.
got it for someone because he was you can call him. He had a dealership and stuff on, and someone had an import, and it was like I didn't really. I just don't like the big B on the monogram. Like I don't like that.
But some of them look good, like S-Class. Brabus looks very good.
Yeah, you can say that. But I think they usually just do the carbon fiber ones. Like they do everything carbon fiber, carbon fiber. Mm.
Some of them also change the engine.
Yeah, they do that. Mm. I'm currently looking into the Brabus. Yeah,
I
the S
wanted
class.
to do automotive, like in engineering,
Mm.
but I don't think it's possible
Bye.
because some of them ask for chemistry in A levels, I think.
Yeah. No, not all of them. What are your subjects?
Physics, chemistry, physics, computer, and maths.
Oh, then I think. Yeah, I don't think you
Yeah,
can do mechanical or the
yep.
what all the automotive. Hmm. That's that. Okay, the S class does look nice. I'm looking at it. Hmm.
I mean, these
So,
Brabus S class are very common in Saudi. I think one
hmm.
of these are in Pakistan too. Someone in
Yeah, we
Islamabad has it.
we've seen. And do you go to like? Can you get like Brabus like customized on like
Order?
yeah,
I don't think so.
like whatever they do is done.
Yeah, they're limited made.
Hmm. This is a GT. Hmm. That's nice.
And some of these customs are very nice. Like in Bugatti, there is one called Hermes Edition. I don't know
Hmm.
if you've seen it. That's also very pretty.
Hmm.
Like
I
they
think.
change all interior and they give like custom Hermes Edition bags.
Yeah, the Hermes edition. Yeah, I know that. Mansoori is also nice.
Yeah.
Wow, I'm looking at them. They don't have a lot of body kits, the Mansoori guys. Brabus has a lot of body kits on it. Mansoori cars.
Mansory has one of the worst color schemes ever.
Yeah, that I was just about to say that. They put blue on an
Like
Audi.
even their interior colors are sometimes blue, light blue, green, pink.
Why do they do that? Oh no, they've got a G wagon in a neon green.
Yeah, they have random colors. I don't know why. I mean, I saw a Bentley with green interior.
That is just too much. I don't think I would want that ever. My mother used to always, she used to love cars in monotone colors, like gray, black, and stuff. So we always had cars like those, gray, like single colored cars. I always wanted a red car. I wanted a Ferrari, always. The problem in Pakistan is, and even if you do get your hands on a very super car, big car, you're going to have to pay so much tax because obviously, if you're getting a Ferrari, you're going to be really, really rich. So if that is the case, then they're going to give you so much tax. Like the 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 price of the car goes up like three times. So you're paying for three
For
cars, yeah, and you're getting one.
yeah,
So that is why a lot of people don't do that. Like in Pakistan, usually the the cars that we have, like Porsches are nice. Over here, we've got a lot of them. Mercedes and BMWs, like we just deal with them, and Audis, obviously. We don't go for the big
I mean,
supercars like
even for
Lamborghini.
Mercedes and BMW, they get the base variant and then convert it because it costs them cheaper.
You can do that.
Like buying an M3 directly and getting a normal 3 Series is much better price wise.
You're right regarding that. Which of these German cars do you like?
Mm, BMW M3.
Hmm. Usually people say that BMW is the best German car there is.
Speed wise, yes. Luxury versus Mercedes.
Yeah, Mercedes actually. And Audi, they always say that it's the lowest out of all of them. I don't know why. I kind of like the Audis. But wow, if you go to the Ferrari uh, website, they actually show you cars according to their engine, like a V12 engine, a V6 engine, and apparently none of them are available. Wow.
You need custom invitation from them in order to get directly, otherwise you have to pay MSRP.
Yeah, I'm thinking of that too. Why would they sell me a Ferrari? They also sell hybrid cars. Wow, I did not know that. Special series. La Ferrari. Pasha, are you done?
Yeah, Mr. But I got a completely different answer.
Okay, no worries. I'm just looking at the cars. Okay. Yes, what should we do? Okay, Nofal, guide us through. How should I solve this? Which side did you choose first of all, Nofal?
Left.
Okay, so Nofal chose sine theta over sine theta plus cos theta plus cos theta over sine theta minus cos theta. All right, and you have to convert it to tan square theta and tan square theta. Yes. What should we do?
And then I cross multiplied it.
Can you cross multiply? Like this is plus. You're supposed to take LCM.
Yes, like sine theta plus sine theta minus cos
Okay.
theta.
Okay. I get what you're saying.
So like yes,
Minus cos theta plus cos theta times. First, we're taking LCM. Cos theta over sine theta plus cos theta multiplied to sine theta minus cos theta. Okay. Now what's going to happen? Okay, simplify. So I'm going to get sine square theta minus sine theta cos theta plus cos sine theta cos theta sine theta plus cos square theta over. Now at the bottom, I can think of it as, the same way, what you may call your sine theta plus cos theta and times sine theta minus cos theta is actually can be written down as sine
sine
square
square
theta
theta plus cos square theta.
minus cos square theta. Sorry, Nufal, minus. It's a square minus b square. Always remember.
Yes.
Okay. Now what's going to happen is that if I've simplified this further, now I'm going to have to simplify the above part. So this is going to cancel out these two because they're opposite signs. I'm going to have to cancel them out. And what are they going to be in turn? So I'm going to have sine square theta plus cos square theta over sine square theta minus cos square theta. Now I need tan. How do I get to that? Yes, I need tan on both sides, and I also need 1. What should I do? Yes, guys. What
We can
can
get the one by Sine theta and cos theta, so it will become 1.
No, sorry. The above part, you were telling me I should write over here as 1.
Yeah,
Okay. And at the bottom, it's
sine
sine
square
square
theta
theta.
minus cos square theta.
Okay. Then what should I do? Now I
And we
need
can move it, divide it again, and then we can move it to the other side.
divide it again with what?
Cos square theta.
Okay. You're saying that I do it on purpose.
Yes.
Okay. You're saying that I divide the entire thing by.
Basically, we want to take the left part towards right.
Sorry. Could you say that again?
We want to take left part to right so that we can match it.
Mm-hmm. Yes, obviously. So I should divide everything with one, like multiply it with cos 1 over cos theta, right? That is what you're.
Yes. Yes.
Okay. Now, when that is the case, what is going to happen? I'm going to get 1 over cos theta over sine square theta minus cos square theta over cos theta, like dividing it. Then if I take this down, what do I get? So I'm going to get 1 over cos theta times cos theta over sine square theta minus cos square theta. Yes, Nofal, should I do now?
We will now cut cos theta with cos theta. No.
So if I cut cos theta with cos theta, I'm going to get back to the original position.
You see, we need to make sine square theta over cos square theta in order to make it tan square theta.
Yes. So what should I do? I need to have sine square theta on the top,
And cos square
and
theta on
cos
the
square
bottom
theta
in
at
order
the
to make it
bottom.
tan square theta.
Yes. What should I do? Mhm. What can be done?
I think we messed up on one step.
Okay, what did you do? You tell me your
Is
step.
I
How did you
simply
do it?
1 over sine square theta minus cos square theta, and I made it by dividing cos square theta 1 over sine square theta over cos square theta minus 1.
Okay.
Because when we change the formula,
Mm-hmm. One thing that can be done is that, for example, at up to this point, we are correct. Sine square theta. And now I need tan square theta plus 1 at the top. And I need tan square theta minus 1 down below. Right? I need these two things. In order to get these two things, I need to make sure that both of them, my sine square theta above and my cos square theta, it should be like this. I need to be getting some sort of, there needs to be some sort of way where I'm getting sine square theta in the numerator and I'm getting cos square theta in the denominator. Clear? Now,
yes,
in order to do that, what should I do?
we can make the first part 1 and like sine square theta divided by cos square theta and cos square theta divided by cos square theta.
Okay, we can do that. How do I do that? Okay, tell me.
Like before how we went to 1, first part will be 1. So 1 over sine square. Before how we wrote,
Mm-hmm. Yes,
like we will
okay.
write 1 divided by sine square theta minus cos square theta, and that will be divided by cos square theta.
Mm-hmm. Okay. What I can do, one more thing is, wait, I'll explain this to you. If I let this be, if it is, wait, let us solve it like this. If it is still 1 times 1 over cos theta. Oh, If I divide the entire thing with 1 over 1 times cos theta over sine square theta minus cos square theta is going to be over cos square theta or cos theta. Clear, Noble? Now what should I do? I need to get tan.
But we need cos square theta on bottom, not cos theta.
Yes. So I should have multiplied it with cos square theta.
Yes.
All right. So if I multiply it with cos square theta, what am I going to get? Cos square theta, cos square theta. Okay, now what should I do?
No, 1 over sine square theta. Now we will sine square theta over cos square theta will be tan square theta. Cos square theta over cos square theta will equals to -1.
Okay, 1 over cos square theta, but let me write it down, times sine square theta minus cos square theta over cos square theta. Oh, sorry, I've written it opposite.
Now,
Okay.
what if we write it step by step?
Wait, let me. Cos square theta. Like this. Now,
Just
cos square
yes.
theta can be written down as, or the cos square theta at the top can be written down as 1 minus sine square theta, right?
Mm,
I can write it down like this. Or, okay, this can be written, it can be written down like this as well. All right. And at the bottom, I'm getting cos square theta alone. And I've got sine theta minus cos square theta. I need to somehow get that, what you may call the sine theta to go away from this. All right. And if I get the sine theta away from this, now what is going to happen? Wait, I'll explain this to you. This is going to be cos theta. Now what should I do? Yes, no. I've gotten this as well.
I don't know. I didn't get to this step.
Okay. Parsa has gone completely silent. Parsa, is this clear?
Yeah.
Okay. What has happened so far is that I've multiplied it with 1 over cos square theta because I need cos square theta in my, what you may call, um, I need my cos square theta in my denominator and my sine square theta in my numerator, right? Now what's going to happen is that simply, again, one thing that is going to be the case is, wait, I'll tell you. We can even solve this in a much more simpler way. I can divide it. How so? I can write 1 over 1 over cos square theta. This is how you guys will get it. And then I can, separate the fraction. I can even separate the fraction. So it can be what you may call sine square theta.
That's exactly what I said.
Yes. Well done, Nofal. Cos square theta over cos square theta. Then what should I do, Nofal?
Then sine square theta over cos square theta is equals to tan square theta and minus cos square theta over cos square theta is equals to 1.
No, but what about the numerator? It should be 1 over cos square theta. Okay. And at the bottom, you're going
But
to
why are
get
we
tan
even
square
getting
theta.
1 over cos square theta above?
Sorry?
Why are we getting 1 over cos square theta above?
Why will we not? Because we're dividing the entire thing with 1 over 1 cos square theta. And we already had 1 at the top. Or should I have not done this so? Yes. This is the mistake that I wanted you guys to point out, but you should not have. You did not. We can leave it as it is. And if I leave it as it is, what is going to happen to it? It is going to remain. I can do it the same way with the above part as well. sine square theta plus cos square theta over cos square theta. Clear? So the top part can be written just like the bottom part because both two parts are same and the only difference is that it's plus 1. And now what's going to happen? Sine square theta over cos square theta is tan square theta. Tan square theta. And plus cos square theta over cos square theta is 1 minus 1. Bingo. Is this clear, guys? This is what happens. Okay. Sometimes something may look like a identity to you. This was perfectly all right. Sine square theta plus cos square theta was perfectly all right. But because of the fact that, we did not require it then. The same case example with the one that I gave regarding the car one and the previous one. You can, use the identity, but we didn't need to. And the reason why we did not need to is because of the fact that, oh, wait, let me just write it down. So it was like this. Because we needed to get tan above. And in order to get tan in my numerator as well, I needed some sort of sine cos in my, I needed sine theta in my numerator or cos theta in my numerator. Is this clear, guys? Any issues with this? Parsa, did you get this?
Yeah, I'm sorry, I got that.
No fun?
Yes, sir.
All right. Okay. That will be it for today. So this is how a question can become difficult to you as well. And the question would have been more difficult if it had been tan square theta and no, because then you would have had to take LCM, then you would have had to split the fraction. So this is how the question was solved. Okay. I'll see you guys on Thursday. Keep smiling. Allah Hafiz. Bye bye.
Thank you, sir. Take care.
Allah Hafiz.